you know. Okay, guys, I've started the recording, and today we're going to cover everything for your syllabus tomorrow, because tomorrow is your paper, right? So I want you guys as relaxed as possible. You guys have done it all. You guys have, practiced a lot. You guys have done everything. Up until this point, whatever you've done, just remember, jitna ho sakta tha, you guys have done it all, right? Isha is saying, sir, can you speak English more, please? I'll only speak in English because you're going to give the paper in English. So I'll only speak English until and unless I want to crack a joke in Urdu or Pashto or whatnot, right? So, or Punjabi even. So today, what I want to do is I just want to go over the entire syllabus, and I will look into the objectives of the syllabus and give you, all the questions related to a particular objective, right? And because once we do that, you will have a clear understanding, acha, from this particular chapter, these are the type of questions which can be tested from this chapter or this point right here. These are the type of questions that can be tested, and other than what we are going to do to this today, nothing is going to be tested. So have faith in me. They can change the names here and there. They can work around with Ajmal and Afsar and Roy and Ray and Jaymond and Damon, but they cannot change the core concepts and the core objectives of a syllabus. The syllabus is a very structured syllabus. I will be available till 3 a.m. tonight for answering all your queries. After 3 a.m., obviously, I've been awake since 4 a.m. So then, 23 hours of being awake will take a toll on me as well, right? So I'll be answering every single question. Just keep on tagging me. You guys can call me if you guys feel, panicked, or if you have a question which is very crucial. You guys could straight up call me. My number is 0333 5694666. Yeah, so you guys can even call me. I'll be glad. Please don't call me randomly just to discuss gupshup, just to do gupshup, but call me if you guys genuinely have a query regarding something, right? So direct call kiya kare, because tonight everything is for you guys. It's for the kids of this country and for other countries, obviously, and it's for kids in general, for students who have been suffering through the hands of these big institutions, so-called institutions, who are just लैंड ग्रैबिंग कह दूं, मनी ग्रैबिंग कह दूं, क्या कह दूं. चलो जी, let's start. Sir, group में आपके साथ बगावत हो रही है. It's fine. Yeah, I can't have more than 100 participants. I'm not going to purchase the what's it called, the increased quantities participants. So it's fine. You guys, it'll be uploaded onto YouTube. Chillax, huh? It's O levels. IGCSE is the same. Zara, it's the same. It's the same. 2023 to 2025, it's 99% is the same. Trust me, huh? Because I'm going over all the type of questions. So don't worry, huh? It's all the same. Okay, let's start off with the objectives of the syllabus. Let's start off with chapter number 1. I'm just going to skip all of this BS, and I'm just going to go over theory stuff, right? So he's saying, hey, question, the states of matter, that's chapter number 1. It says, state the distinguishing properties of solids, liquids, and gases, right? Now, you guys have learned this, if you talk about solids, if you talk about liquids, if you talk about gases, he can test these things, he can test what? He can say, hey, what is the volume of solids? Is it fixed or is it not fixed? I'll say, hey, solids have a fixed volume. Liquids, they also have a fixed volume. Please remember, the volume is obviously fixed. The shape can change. If you take 5 milliliters of water in a cup, it'll take the shape of the cup, but it'll still be 5 milliliters. If you put it into a jug, it'll still be 5 milliliters. It'll take the shape of the jug, but it'll still be 5 milliliters, right? So volume is fixed. But for gas, the volume is not fixed, right? Because if there's a gas in a room, it'll occupy the volume of the entire room. If it's in a syringe, it'll occupy the volume of the syringe. If you fart inside the washroom, it'll occupy the entire, volume of the washroom, right? Now, if you talk about shapes of solid, liquids, and gases, the examiner can ask you, hey, what do we know about solid shapes? Is it fixed or not fixed? I'll say, hey, solids have a fixed shape. It's a definite shape. Liquids, they do not have a fixed shape. They take the shape of the container, right? So they take the shape of container and they do not have a fixed shape. And similarly, gases also, they do not have a fixed shape. They also take the shape of containers, right? Now, once we talked about shapes, then some other distinguishing properties between these three. Sorry, don't mind my writing. I'm just quickly going over things, right? Because we have to cover the entire syllabus. And I'm going to cover every single question of a particular topic. Then they can ask you about, volume, shape, ho gaya. Then they can ask you about compression. Compression, solids, we know. What is compression? By the way, what's compression? Compression is the reduction in volume and when a force is applied, right? The reduction in volume when a force is applied, that's what compression is. The reduction in volume when a force is applied. Reduction in volume when a force is applied. Reduction in volume by when a force is applied, you know. And then if I talk about compressions, can solids be compressed? No, they're incompressible. Liquids are almost incompressible, almost incompressible. I'll write almost in the brackets, right? So almost incompressible as well. But gases, they can easily be compressed. Now, the theoretical question for this, the only theoretical question that can be asked is going to be, hey, why? The why can be asked for you guys, right? So why are solids incompressible? Why are liquids almost incompressible? And why are gases easily compressed? Realize it has to do with their arrangement. It has to do with how they are, how the particle separation, right? Not the arrangement, but the particle separation largely. So let me tell you the why quickly. The why exactly ऐसे लिखे हैं. So now this is probably, I've drawn shapes for solid, liquids, and gases. And what I'll realize is that if you look at the particle separation of solids, solid particles are tightly packed. They are close together. The liquid particles, they have some spaces, but largely speaking, they are also close together, right? They're close together, but slightly separated. And if I talk about the particle separation of gases, they are far and apart from each other. Now, why are solids incompressible? देखिए, compression is the reduction in volume by the application of force. And why would volume reduce? Because of these spaces. These spaces are called intermolecular spaces. Intermolecular spaces, right here. Right here, intermolecular spaces. Now, what you'll realize is that solids, they have no spaces between the particles, or you could say no intermolecular spaces between the particles. That's what you're going to say. What am I going to say? Hey, solids are incompressible because they have no intermolecular spaces, or you could even say spaces. Just spaces is also fine. No intermolecular spaces between particles, or no spaces between particles. Hence, they can't be compressed, because if you apply force, they're already close together. How can you compress it? Even liquids, they are also, this is not drawn to scale, but liquid particles are also, close together, but slightly separated. So that's why I said they're also almost incompressible. Please, जो अल्फाज मैं अभी कह रहा हूं वही लिखना है, अब अपने से टर्नेलिया ना मारे. So for liquids, I'm also going to say because of no spaces, we won't use the word no spaces, but because of very little spaces between the particles, I'd say they are incompressible. Very little intermolecular spaces between particles, right? For gases, why are they easily compressed? Because if you realize, there are huge spaces between particles, right? These are the spaces right here. Sorry, I'm not gonna, these are the spaces, right? The intermolecular spaces. So if I apply force, these particles are gonna come close together, right? And that's why I'd say they're gonna be compressed, right? And I can give you an example for this. If gas particles are like, in a container, gas particles are here, right here, there are large intermolecular spaces. Look, there's a lot of space. So if I apply force right here, what's going to happen is that these particles, they're going to come close together, boom, 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 and you'll realize that they have been compressed. They have been made to come closer together. So why are gases easily compressed? Why are gases easily compressed? Because they have large intermolecular spaces between particles. This is what you will write. इसके आगे अगर आपने अपनी टर्नेलिया मानी वो आपकी मर्जी है, but because they have large intermolecular spaces between particles, that yes break मिलेगी. तो large intermolecular spaces between particles, right? Intermolecular molecules के बीच में या particles के बीच में जो spaces हैं, that's what I mean by intermolecular space. You could even just say large spaces between particles. That's it. That's also absolutely fine. That's the theoretical aspect of this. So we've covered the first bit. And yes, he can also ask you about the density, which he will not. It's very highly unlikely, but solids have the highest density. Liquids have, relative to solids, they have low density, but relative to gases, they have higher density. So it's relatively low density, and then gases have lowest density. So highest, high, and lowest, whatever, right? But you need to just realize that solids have the highest, then liquids is higher than gases, but lower than solids, and gases have the lowest density. And the Y will not be tested for this. The Y is not in your course, but from your physics, you know that density, or how do you write the symbol of density? Density equals mass over volume. So for solids, there's, for a particular volume, for the same amount of volume, because solids have more particles, they pack in more mass. So solids have more particles, they have more mass. If the Y comes, you're just going to say, hey, solids have more mass in the same volume, compared to liquid or gas. So for the same volume, solids, or you could say like this, it's better to use this terminology, for the same, I'm just fixing the English. So for the same volume, if you take 5 cm cube of solid, liquid, or gas for the same volume, you will have more particles of solid, therefore more mass of solid, right? So for the same volume, there are more solid particles versus liquid particles versus gas particles, therefore more mass, and therefore greater density. This is not going to be asked, but just to be on the safe side. Density का क्या symbol है? डेंसिटी कैसे लिखते हैं? ये ऐसे लिखते हैं डेंसिटी, मुझसे भूल ही गया फिजिक्स में कैसे लिखते हैं, जैसे भी लिखते हैं, that's the why, but it's not going to be tested. Don't sweat about it. Describe the structures of solids, liquids, gases in terms of particle separation, arrangement and motion. Realize that these are three other things. हाँ, YouTube पे upload करूंगा. So these are three different things. Students confuse this. Remember, let's talk about this. So solids, liquids and gases, So if you talk about solid, liquids and gases, what's the arrangement? Arrangement को हम structure भी कहते हैं. We know it as structure as well. So what's the structure / arrangement of solids, liquids and gases? Realize when you talk about the structure or arrangement of solids, liquid and gases, we talk about their pattern. So if you can see a pattern, you're going to say it's a regular structure. So solids, you can see a pattern right here. But liquids, you can't really see a pattern. It's like this, they're close together but slightly separated, something like this, so you can't see a pattern, right? So for solids, because I can see a pattern, I'll say it has a regular arrangement of particles. I'll say it's a regular arrangement of particles, that's it. And you could also call it a lattice of particles. Remember, lattice is just a fancy word of saying regular arrangement. Remember, lattice is just a fancy word of saying regular arrangement. So it's a regular arrangement of particles, or it's a lattice of particles. It's the same thing. Now, liquids, it has an irregular arrangement, or you could even say it has a random arrangement, irregular or random, because you can't see a pattern. Can you see a pattern? No, sir, I can't. Therefore, it's an irregular arrangement or random arrangement. Then for gases, again, it's a random arrangement, totally random arrangement, because I don't know, I can't see a pattern. Ek east mein, ek west mein, one is in north, one is in south, whatever, blah, 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 and that's it, right? Then let's talk about the particle separation. Remember, arrangement, particle separation, motion, they are three different things, and students tend to confuse them. Now, if you talk about particle separation, people are sharing your call. It's fine. Okay, if you talk about particle separation, how are the particles separated? Are they close together or are they not close? Look at the particles. What is their separation? Are they separated? No, they're close together. So I'm going to say, hey, they're close together. If I talk about liquids, they are also close together. Realize that liquid particles are also touching. They are close together. They're touching here. They're also touching. They're also close together, but they're slightly separated. So close together, but slightly separated. Close together, but slightly separated. That's why I said they're almost incompressible. Almost, because there's just a little space for them to be compressed, but because that is due to high force. In O levels, we're going to say they're almost incompressible. Yeah. And if an MCQ comes, MCQ mein again, they're incompressible. Yeah. So that's the reason, because they're close together. There are no large intermolecular spaces, no large spaces between the liquid particles, no large spaces between the solid particles, but yes, large spaces between the gas particles. Therefore, they can be compressed. Particle separation of gas. How are they separated? No, they are far and apart. They're separated indeed. So I'm just gonna say, hey, they are far and apart. Then comes the motion. So what about the motion? You know that solid particles, they are close together and they're tightly packed, close together. So what's their motion? They vibrate about a fixed position. That's it. Boom shakalaka. And then if you talk about the liquid particles, they slide over each other, right? So slide over each other. I've written close together but slightly separated. Khadija, I've written close together but slightly separated. Yeah? And then motion of liquids, what's the motion? They slide over each other. Sorry for my pathetic writing. I'm sorry. I have to be a little quick. And then for gases, how do they move? They have a random motion, but you have to write two things for gases. They have a random motion at high speeds. So random motion, but they also have the highest speeds, right? And you need to understand that gases, if I also talk about the energy for gases, gases have the highest energies. Gases particles have the highest energy compared to liquid particles, and then liquids have higher energies than solids, right? So gases have high energies, that's why they move at high speeds, because of high energy, right? But then liquids have higher energy than solids but lower than gases. Liquid particles and solid particles have the least energy, right? They're close together, you know. This is like a final episode of a season. Yes. And then we're done with this. So describe the structures. Boom, boom, boom. We've described them in terms of particle separation, arrangement, and motion. Then it says describe changes of state in terms of melting, boiling, evaporating, freezing, and condenses. देखिए state changes of state theory में क्या test होता है? You know what melting is. Melting, I'm just going to say it. I'm not going to write it, you know. I'm just going to say it. Melting, freezing, boiling, condensing, and then we're going to look at evaporation. And then obviously we'll also look at sublimation. Nobody cares. Yeah? So if you talk about the process, please, if you talk about the process, melting is the process of converting a solid into a liquid. It's a process. Remember, highlight this. It's a process, process, process. Then freezing. Freezing is a process of converting a liquid into a solid. Boiling is a process of converting a liquid into a gas. Condensing or condensation is the process of converting a liquid, a gas into a liquid. Sublimation. Now, sublimation is the process, please focus on this process of converting a solid directly into a gas without being converted into a liquid. Liquid phase आता ही नहीं है, without being converted, without converting to a liquid, without converting to a liquid. There won't be a cliffhanger. I swear I'll be with you till 3 a.m. Don't worry. What is gas to solid dielectric? That's called resublimation, and that's not in your course. But resublimation is gas directly converting into, it's the reverse of sublimation. So resublimation, gas directly converting into a solid without converting into a liquid, without converting to a liquid. तो दोनों में liquid phase skip हो जाता है. क्यों skip हो जाता है? Not in your course, right? And then one more thing, before I teach you melting, freezing, boiling, and condensation, that's the process, right? And then before I go into this, I skipped something right here, which is not written, but I need to talk about that. The reason for all of these properties, where did it go? The reason for all of these properties is what? What is the reason for arrangement, particle separation, and motion? What is the reason for this? The reason for this is intermolecular forces of attraction. Intermolecular forces of attraction are basically the gluing forces that exists between these particles. This gluing force. Now you'll realize that solids have the strongest intermolecular forces of attraction. It has the strongest gluing flows. That's why the particles are close together. The liquids, they have, relatively weak intermolecular force of attraction compared to solids. That's why they're close together but slightly separated. And gases have the weakest intermolecular forces of attraction. And that is the reason for all of these properties. Why do gases have a random arrangement? Because they have weakest intermolecular force of attraction. The particle separation is they are far and apart from each other. They have random motion at high speeds and whatnot, right? So they have weakest intermolecular force of attraction. That's why also they have highest energies. They have highest energy, weak. So everything is related to intermolecular forces of attraction. There's no covalent bonding in this case that I'm talking about. I'm not talking about covalent bonding here. Bonding की बात ही नहीं हो रही. I'm talking about intermolecular forces of attraction. These are just gluing forces that exists between particles, right? That's what kinetic particle theory tells us. That, acha, one more thing about kinetic particle theory. Before I go into these processes, one more thing about kinetic particle theory. Realize that liquid particles and gas particles, they are both moving randomly. Remember, motion random ही है. It has a random motion, right? They do have a random motion, but you realize that they have difference, right? So liquid particles, they slide over each other like in waves. So waves may, you see that liquid particles are sliding. The waves are basically going on top of each other, sliding over and past each other. So, but you realize if I talk about the particles motion, is it random or is it not random? It's random. Particle motion is random because that's what kinetic particle, even for solids, the motion is random. Remember, the motion is random. They vibrate about a fixed position in a random motion. But and that's what kinetic particle theory tells us. What does the kinetic particle theory tells us? That all particles are in a constant random motion. Brownian motion has been removed from your syllabus. So all particles are in a constant random motion, right? Even if you look at the chair right here, the table, if you zoom in, they're going to be in constant random motion, and the random motion for solids is not in your course, but for liquids and gases, they can say, hey, do liquids and gases have a random motion? Absolutely, they do. Write it. They do have a random motion, but when they ask you about the motion, you're going to write, hey, liquids, they are slightly, they slide over each other, and gases, they have a random motion at high speeds. Done. Acha ji. So now coming back to the processes, melting, freezing, boiling, condensing, sublimation, that's the processor. And if we talk about the melting point now let's talk about melting point. Let's talk about freezing point. Let's talk about condensation point. Let's talk about boiling point. What's the difference between the process and the point? Remember, the melting point is the constant temperature. It's the constant temperature at which a solid changes its state into a liquid. The freezing point, it's the constant temperature at which a liquid changes its state into a solid. The boiling point is the constant temperature at which a liquid changes its state into a gas. The condensation point is the constant temperature at which a gas changes its state into a liquid. It's not a point, it's a constant temperature. Please, apne se ab nahi, no specific, it's the constant temperature. Write the same. This is highlighted in the marking scheme. It's the constant temperature. Now, why is it constant? I'll tell you that in a moment, right? But when you talk about the melting point, and for H2O, you need to know for H2O. What's the melting point for H2O? It's 0 degrees Celsius. What's the freezing point for H2O? What's that constant temperature at which H2O liquid will go into H2O solid? That's also 0 degrees Celsius. And boiling point and condensation point for H2O, pure H2O, that's also H2O. Kya ho gaya? What happened? Can everybody see the screen? Yes? Acha, chalo. Everybody can see the screen. Chalo, but perfect. So for condensation and for boiling, it's also 100 degrees Celsius. Now for H2O, right? For ethanol, it's 78 degrees Celsius. That's the boiling point, but we don't care. Now the question is, sir, question kya banta hai? Question ye hai, janabe wala, ki sir, what do you call H2O in the solid state, in the liquid state, in the gaseous state? Remember, in solid state, H2O is called ice. In the liquid state, it's called water. And in the gaseous state, it's called steam. Yeah. And one more thing to understand and to realize, you guys might be wondering, sir, why is the melting point and the freezing point the same thing? Why is the boiling point and the condensation point the same thing? Why is this 100 degrees Celsius? Why is this 0? And why is this 0? I'll teach you that when I teach you heating and cooling curves, but realize कि देखिए, melting happens when you heat it. Freezing happens when you cool it. Boiling happens when you heat it. And condensing happens when you cool it. So the only difference between melting point and freezing point is whether you're heating it or whether you're cooling it. If you're heating it, you call it the melting point. If you're cooling it, you call it the freezing point. If you're heating it, you call it the boiling point. If you're cooling it, you call it the condensation point, or the condensation point, right? And I'll teach you that through cooling curves, but realize that the melting point, freezing point is the same thing. The condensation point and the boiling point is the same thing, right? It's the same temperature, and that is what is tested in heating and cooling curves. But before we go into that, we're done with this part of the syllabus. Number 4, describe the you guys might think we're going slow, but this is the lengthiest chapter. Iske baad bahut tez hai cheezein. Describe the effects of temperature and pressure on volumes of gases, right? So first, let's talk about the effect of temperature and pressure on volume of gas. Simple kahani hai. Let's talk about gases. So here we have some gas particles, right, Reno, and here we have some gas particles, and I've applied force to it, right? The piston was here before, and now it's here before. So now the gas particles are pushed closer together. Now, if I increase pressure, this is increasing pressure, aka going from A to B. If I increase the pressure, meaning I add force right here, and I add force per unit area, which is pressure. If I increase the pressure and go from A to B, what happens to the particle's volume? This is not physics. You're not going to say that increase in pressure is inversely proportional to volume, therefore the volume is going to decrease. You're going to get 1 mark only. It's a 2-mark question. What will I say? Increase in pressure, it says in terms of particles. Tell me what happens to the particles. Where is it? Tell me what happens to, in terms of kinetic particle theory. That's what it's going to say. In terms of kinetic particle theory, what happens to the particles? I'll cover everything, chill. So what happens to the particles? If I increase the pressure, the particles are pushed closer together. And then because they are pushed closer together, therefore the pressure, therefore the volume decreases, right? Going from A to B. And that's what's true. That's what happens to particles. They're pushed closer together. And there is a recent question that was tested in the 2024 paper in which it was talking about iodine. It was talking about iodine right here. और iodine के बारे में वो बात कर रहा था और वो कह रहा था कि यार iodine में it was showing a reversible reaction, somewhat of a reversible reaction. And it was talking about iodine purple vapors, right? Iodine gas is purple vapors. Iodine gas is purple vapors. And it was some sort of a reversible reaction where when you increase the pressure, you went from purple vapors to some colorless gas. When I increased the pressure, you went from purple vapor to some colorless gas because of equilibrium. वो हम बाद में पढ़ते हैं. But because of equilibrium, you went from purple vapors to colorless gas. But the examiner asked this particularly कि initially, before the equilibrium shifted, initially, when I increased the pressure, the purple color was more concentrated. Why was it more concentrated? Before it went to colorless gas, initially when you increase the pressure, the purple color became more concentrated and then it went to colorless. Why did it become more concentrated? Because the particles were pushed closer together. So the purple color was more concentrated. So remember, always think from the perspective of particles. What happens to the particles? So particles का क्या करना है? Particles, when you increase the pressure, particles are pushed closer together. So let's suppose this was iodine gas right here. And it was pale purple. Let's suppose this was iodine gas and it was pale purple. Now I've increased the pressure. Can you tell me, would it be pale purple or would it become stronger purple? Pale purple, stronger. It would become darker purple. Yes, it will become darker in color, darker purple. Why? The examiner asks why, because the particles are pushed closer together. Why particles are pushed closer together? Then what if I go from B to A? Do it yourself. What if I go from B to A, aka decreasing the pressure? What if I decrease the pressure? What if I decrease the pressure? What if I decrease the pressure? What will happen to the volume of gas? Decreasing the pressure, what will happen to the volume of gas? What will volume? I'm not talking about the color. Volume. Volume, what will happen to the volume? It'll increase. Why? Explain in terms of particles, kinetic particle theory. Why? Because the gas particles are now spread apart or are far apart, spread apart or far apart, whatever, right? So that's what's going to happen. And you're going to go from darker color to lighter purple color, right? Paler purple color, right? Because now particles are further apart from each other. If, like, for example, if you take, ruhavza and you just, put ruhavza on a same point, on a white page, put it on the same point, it'll be very dark red. But if you just take a ruhavza droplet and spread it throughout the paper, it'll become lighter red. अपने से अब अपने से प्लीज अब अपने से आंसर्स ना लिखें. That's the terminology of the paper and that's what I'll be using, right? So this is the effect. If you increase the pressure, particles move closer together, particles are pushed closer together, and the volume will decrease. If you decrease the pressure, the particles are going to be far apart and the volume will increase. 2-mark question, that's going to definitely come. So ये खत्म हो गया. अब what is the effect of temperature in terms of kinetic particle theory? Explain करना है. ये 6 और 4 एक ही चीज है, right? So explain in terms of kinetic particle theory. Now for temperature, think about it. Temperature की अगर हम बात करें जनाब वाला, so if I increase temperature, what's going to happen? Increase in temperature, you know that there's going to be increase in kinetic energy of particles, because temperature and kinetic energy is directly related, huh? So if you increase the temperature, the kinetic energy of particles would increase, right? And if the kinetic energy of particles increases, you'll realize kinetic energy kya hota hai? You've done this in your physics, half mv square. So what's kinetic energy? If the kinetic, it's the energy due to motion. So if the kinetic energy increases, effectively the speed increases. So increase in temperature increases the kinetic energy of particles. Particles move faster, and if they move faster, they're gonna move further apart from each other. Faster and further apart, because now they have more energy. They're going to move further apart from each other. And further apart means what? Now that you've talked about particles, देखिए पार्टिकल थ्योरी, टॉक अबाउट व्हाट हैपेंस टू द पार्टिकल्स. थॉट प्रोसेस क्या होना चाहिए? हीटिंग एक्सपैंड्स इज रॉन्ग, 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 रॉन्ग. You're not gonna write this because chemistry is related to particles. So if you are gonna say, hey, is increase in temperature increases kinetic energy of particles, examiner is expecting you to write what will happen to the particles. So they move faster, particles move faster, they move further apart, and therefore the volume increases. And reverse is the case for decrease in temperature. So decrease in temperature means there's going to be a decrease in kinetic energy of particles. हमेशा देखें, आपको examiner will always say explain in terms of kinetic particle theory. Explain if there's no collisions involved right here. We're not talking about rate of reaction. Musa, Anas, no rate of reaction here. No concept of collisions, please. No concept of collisions. You realize that this in collisions, collision frequency, students tend to confuse this with rate of reaction. It's not, it's just simple. Kinetic energy increases, move faster, further apart, and boom, volume increases. Kinetic energy decreases, move slower, closer together. No need to write collisions. Collisions are come into account when you talk about rate of reaction. So ye bachche hamesha students get this confused and then they write this here. So rate of reaction is explained, yes. So they move closer together and the volume decreases. That's it. No need to write about frequency of collisions, proportion of collisions, successful collisions. That's all. That all has to do with rate. Idhar to simple baat puchi bhai, volume ko kya ho raha hai? What happens to the volume? So what happens to the volume? Increase in kinetic energy increases the energy of particles. They move faster, further apart, and therefore volume increases. What happens to the volume if you, sir, do you know when to write? How do you know when to write about collisions? When they ask you about rate of reaction. Done. So that's it. That's all you needed to know about this particular bit. And one more thing. Pressure. One more thing, guys. Pressure can also be decreased, and this has never been tested. So my hunch is maybe it's tested this time. Pressure can also be decreased if you change the container size, right? So tell me something. Will A have a higher pressure or will B have a higher pressure? A will have a higher pressure or B will have a. This is a physics question. It's A, obviously. Why? Why is it A? Because it's a smaller container compared to B, and smaller container compared to B. Now you can write about pressure, right? So smaller compared to B, and therefore more. Now you could write about more collisions with walls. Now you could write more collisions with walls of container, more collisions, more bombardment with walls of container, and therefore pressure, more collisions with walls, and therefore pressure will obviously be higher. So this has never been tested, but probably it's a physics question, maybe tested. हाँ, lower volume. Volume की बात नहीं कर रहा, मैं pressure की बात करता. हाँ, obviously A will have a lower volume, B will have a higher volume because A is a smaller container. Yes, if you talk about volume, if you take smaller container B will have lower volume. Why? Why will it have lower volume? Tell me what happens to the particles. Why does it have lower volume? What happens to the particles? Particles are closer in A. Particles are closer in A because it's a smaller container, therefore it'll have a lower volume, obviously. मैं फोर्स में कंप्रेशन की बात नहीं हो रही. खत्म. तो ये देखिए मैं आपको मॉडल आंसर्स दे रहा हूं, तो बस कीप दिस इन माइंड. हाँ, तो 4 भी खत्म और 6 भी खत्म. लेट्स टॉक अबाउट 5. 5 is the most important. Now 5, what is the melting process? What is the freezing solid to liquid? And I'll go for liquid to gas. अब वापस हम आ रहे हैं मेल्टिंग और फ्रीजिंग पे. खत्म करना है. शाबाश. पूरा मैंने हर एक सवाल कराना है, हर एक सवाल कराना है. Done, done, done. Shabash, shabash. So, what happens? How do you melt? How is there a change of state? This is a typical question that comes from 2 to 3 marks sometimes, you know. So, change of state, solid to liquid, liquid to gas. चलिए जी बात करते हैं. Solid to liquid. What happens? How do you go from solid to liquid? You increase the temperature, aka you heat it. You heat the solid. What happens when you heat the solid? Again, if you increase temperature, kinetic energy increases. Increase temperature, kinetic energy increases. So there's an increase in kinetic energy of particles. Done, sir. Increase in kinetic energy of particles. And what happens when there's an increase in kinetic energy of particles? Kinetic energy क्या है? अपने साथ दिमाग में बोले, half mv squared. Mass does not change because it's the same solid. So mass is not changing, but the velocity, the speed is. देखें यही गलती है ना. It's not, you're not asked about volume right here. Volume के बारे में जिधर पूछा था वो हमने लिख लिया. Volume की ये हिसाब किताब है. Now it's change of state. So you have to talk about intermolecular forces, right? So there's increase in kinetic energy of particles, and therefore what happens when there's increase in kinetic energy of particles? Particles vibrate faster. because it's a solid, right? So they vibrate faster, and eventually they vibrate so fast that they move further apart, eventually move further apart, or eventually overcoming the intermolecular forces of attraction, the intermolecular forces of attraction that holds the solid in place, and moving further apart to become a liquid. Done? तो होता क्या है sir? They overcome the intermolecular forces of attraction, because you'll realize at this point, I expect you guys to know that the only difference between solid to liquid and liquid to gas is their intermolecular forces. So if you can somehow overcome the intermolecular forces of attraction that holds the solid in place, if you could somehow break these intermolecular forces of attraction that holds the solid in place, it's going to become a liquid. If you could somehow break these intermolecular forces of attraction or overcome these intermolecular forces of attraction of liquid and make it very weak, this will go into gases. And that's how do you do it? You do it through heating it. Done, sir. So let's talk about it. So increase in temperature, how do you do that? There's heating the solid. Heat the solid, there's increase in temperature, which increase the kinetic energy of particles. They vibrate faster, eventually overcoming the intermolecular forces of attraction that holds the solid in place. That's it. Don't need to write anything else. Now, liquid to gas, again, the same thing. Heat the liquid, heat liquid, or and by heating it, there's increase in temperature of liquid particles. देखिए particles की बात करनी है, which increases the kinetic energy of particles. And if kinetic energy increases, what happens? They move faster and faster. Eventually, what happens? Eventually, overcoming the intermolecular forces of attraction, the IMF, the gluing force that holds the liquid in place, and becomes gases, and particles are now far and apart. You can write this, and particles are far and apart. Or either you could write, and particles are slightly separated now, if you have space and if like the 3-mark question or whatnot. Khadam? Intermolecular force of attraction कह दें ज़्यादा बेहतर है. Bonds की जगह forces of attraction कह दें. It's better to say force of attraction. Then, now the question is, how do you go from liquid to a gas? How do you go from gas to a liquid? Or first, let's go from liquid to solid, Now, if you went from solid to liquid by heating, liquid to solid is freezing, right? That's the process. So how do you change the state? Again, how do you change the state, sir? Sir, you cool it. You cool it in this case, because solid to liquid is, liquid to solid. Liquid to solid is what? Cooling it, cool it. That's what you do to water. Water is liquid, and if you want it in the ice form, what do? You cool it. So cool it. What does cooling does? Decrease in temperature. What does decrease in temperature mean? Decrease in kinetic energy of particles. Please talk about the particles. Please talk about the particles. And therefore, particles move, because kinetic energy is half mv square. हमेशा लिखिए, तो v means speed. So what will happen to particles? Particles move slower and closer together. And therefore, if they move slower and closer together, the intermolecular forces of attraction are strengthened, and you get a beautiful solid. Next. यार, it's not 40 minutes of state of matter. जल्दी करेंगे. This is the lengthiest chapter. It has the most concepts. अच्छा, next. Then if I were to go from a gaseous state to a liquid state, what do? That's called condensation. So what do? I cool it. Gas to liquid, cool it, because gases have more energy. Liquid has less energy. So more to less means what? Cool it. Sir, to cool it, what happens? Decrease in temperature, decreases the kinetic energy of particles. Particles move slower and closer together. The same thing, literally ditto, slower and closer together, and therefore intermolecular force of attraction are strengthened. और इधर आप overcoming completely भी, gas में आप लिख सकते हैं completely overcoming the intermolecular forces of attraction. Then, now one more thing that I like to add here is that if you go from a solid to a liquid and a liquid to a gas, you need to provide heat. You need to provide heat to it. And that's why it's endothermic. You need to provide heat. That's why they're endothermic processes. And if you want to go from a gas to a liquid, and a liquid to a solid, you realize that these are exothermic. Why? Because you have to cool it. And why are these exothermic? Because you realize that gases have higher energy. Gases ki energies are higher. This is just a conceptual understanding. Gases have higher energy than liquids, and then solids have the lowest energy because they have the strongest intermolecular force of attraction. So how do you go from high energy to a little lower energy? How do you go from high energy to low energy? You need to cool it, and once you cool it, those gas particles, they lose heat to the surroundings, or they give out heat to the surroundings, or they release heat to the surroundings, give out thermal energy, heat energy, thermal energy, heat energy to the surroundings. So that's why it makes it exo. Why is it exo? Because when gases go from gases to liquids, it gives out heat energy, it gives out thermal energy, because you realize that gases ki energy is zyada hai liquids ki. So how do you go from more energy to less energy? The gases must give out energy. The gases must give out energy. Sir, आपके अलावा कोई इतने डेप्थ में नहीं करता. Thank you, thank you. Sir, I will leave YouTube comments. Thank you, thank you. It's fine, it's fine. Acha, chalo. Shabash, khatam. So, right, that's endo. The reason why I told you this is because it's going to help us in heating curves and cooling curves. So, khatam ho gaya. Changes of state bhi khatam ho gaya. एक सवाल कराऊंगा. खुदा की कसम, मैं कसम खा के कहता हूं कि इसके अलावा और कुछ भी नहीं आ सकता इन concepts के अलावा. It'll go till I complete the entire syllabus, hopefully in the other 1.5 hours. 5 is over. This is over. Now let's talk about heating and cooling curves. Let's talk about that. Yeah, I'm here for you. Don't worry, I'm here for you. I'm here for you. Acha ji, heating curves and cooling curves. If we talk about heating curves and cooling curves, you'll realize that after every chapter, we'll take 5 minutes break. Acha ji. Then heating curves and cooling curves. Heating curves आपको क्या बताती हैं? Cooling curves आपको क्या बताती हैं? Heating curves tells you how the temperature of a substance changes as it is heated. As it is heated. And cooling curves tells you how the temperature of a substance changes as it is cooled. That's it, and then here you have time, and then here you have temperature, time, temperature, whatever. Now realize that what happens is, let's suppose I start off with solid. So if I start off with solid, I start to heat it. हो जाएगा 3 घंटों में यार, यकीन रखो. If I start off with solid, I start to heat it. And what's going to happen? There's going to be increase in temperature, increase in kinetic energy of particles. My question is, increase in temperature, increase in kinetic energy of particles. My question is are the intermolecular force of attraction overcome in this point? From point A to B, have intermolecular forces start to overcome? Have intermolecular forces started to overcome? No, not right now. There's just a basic increase in temperature. So increase in temperature, kinetic energy increases, particles move faster. That's it. So this can come in your paper from A to B. What is happening from A to B? So please don't mention any intermolecular forces. But you realize that when there's a change of state, now the solid will start to go into a liquid. And from B to C, you basically have two states. From B to C, you also have solid and you also have liquid. Remember, B to C mein, you don't just have a solid, you also have a liquid. It's a mixture of solid and liquid. Yes, Saifullah, you are right. So you have solid state and liquid state, and the temperature remains constant. So whenever there's a state change, the temperature remains constant. State change mein temperature remains constant. State change mein temperature remains constant. And then after all the solid has been converted into a liquid, then the temperatures of the liquid would start to increase. The particles, the kinetic energy increases. The particles, here the kinetic energy remains constant. There's no change in kinetic energy. The temperature is constant, and if the temperature is constant, the kinetic energy is constant, because you realize that if temperature is not changing, kinetic energy will not change, because they're directly proportional to each other. So here, the last time the examiner asked the question, what happens to the kinetic energy from B to C? It remains constant. Why? Because temperature remains constant. Done. Ab liquid mein kya ho raha hai? Again, there's increase in kinetic energy of particles, temperature, because temperature is increase, and temperature increases, particles move faster. But no concept of overcoming the intermolecular force of attraction. Only when the temperature becomes constant, you realize, oh, now the liquid has started to change state into a gas, because the temperature is constant, and constant temperature is right here. And then after all the liquid is converted into a gas, only then will the temperature of the gas start to increase, right? So here, from point C to D and D to E, may the kinetic energy is constant, the temperature is constant, And yes, and the forces of the intermolecular forces of attraction are being overcome right here from D to E. The intermolecular forces of attraction are being overcome from B to C, right? And that is the reason why the temperature is constant. Why is melting point a constant temperature? Why is freezing point a constant temperature? Which one is long and which one is short? You'll realize that this one right here, this is longer than this one. Why? Not a part of your course. But if he asks you to draw it, he wouldn't really test you on this because I did not have any space. But liquid to gas is a longer line than solid to liquid. If you did not know it, take my word for it, write it, you will learn it in A2 physics. The reason for it is the work done by gas, the work done by liquid particles is more, not a part of your course. But if you want to draw this, this line is not drawn to scale. This line should be greater. Liquid to gas line should be greater than solid to gas. I just did not have enough space here. But why? Not in your course. Now, my question is, why is the temperature constant? ये सवाल टिट्टो सवाल. Why is the temperature constant? The temperature is constant in a heating curve right here from B to C or D to E. It's because the heat energy, the temperature that you're providing, the heat energy is used to overcome the intermolecular forces of attraction, used to overcome the IMF, the intermolecular forces of attraction. And or you could say it is used to break the bonds between solid particles, or used to overcome, the thermal energy is used to overcome the intermolecular force of attraction and not raise the temperature. That's why in physics you would have learned this. I don't know if you have, it's called latent heat. Latent means hidden. It's the hidden heat, latent heat, but nobody cares as of now. So it's the heat energy used to overcome the intermolecular forces and not raise the temperature, because that energy is being used to overcome, not raise temp. This is in your course, this part is in your course, this will come, this will come, this will come. जो है वो मैं करा रहा हूँ, इसके अलावा कुछ भी नहीं है. अच्छा, next. Now, cooling curve, let's suppose I started off with a gaseous state. So after a gaseous state, the temperature decreases, kinetic energy decreases, and particles move slower, but there's no overcoming. Aman, chill, we'll reach to acid, bases and salts. हो जाएगा. Then gas starts to go into a liquid here, and after all the gas goes into a liquid, then the liquid further decreases in temperature, and then there's a liquid to solid right here, and then the solid decreases in temperature. Right now the question is, why is this temperature constant? No teacher has taught this, but it has never been tested before, but it can be tested in this particular sir 10 extra लोगों को WhatsApp call पे screen share करके class दिलवा रहा हूँ. Awesome, Hamza. Now he has never tested this before, but it's a very simple answer. Why is the temperature constant if you cool it? Why is the temperature constant if you cool it? इधर तो sense बना रही थी कि heat energy is used to overcome the intermolecular force of attraction, and that is the sole reason as to why there's not an increase in temperature. But here, why is the temperature constant? The temperature is constant because when gas goes into a liquid, it's exothermic. It gives out heat. I told you, because gases have more energies than liquid. So gases going into a liquid gives out heat. They have this strengthened intermolecular force of attraction. They give out heat. It's exothermic. And what happens is this heat that is given out, this heat balances the cooling effect. You are cooling it, but when it gives out heat, it balances the cooling effect. And remember, at this point, you have from, let's suppose this is A, B, C, D, E, F. So remember, from B to C, you have two states, gas and liquid. From D to E, you have two states, liquid and solids. Yes, I've taught this in class. So this is why B to C and D to E are constant temperature, because it's exothermic, gives out heat, and this heat balances the cooling effect. And after all the intermolecular forces of attraction have been strengthened, gas to liquid is a longer line than this. But nobody cares. Just take my word for it. What's cooling effect? The cooling that you're doing, aapne freezer mein rakha hai, you've put it into a freezer or a fridge, so you're cooling it. Yeah, a freezer. You've put it into a freezer or a fridge, so you're cooling it, What is my Instagram handle? It's SULLI_KHAN. And enjoy. Now, that's done. So heating, cooling curves done, everything done. Acha, one more thing, please guys realize that what if it may not be tested in theory that much, but what if I say, okay, I say here you have a liquid. What is D to E? What process is this? Please, what process is D to E? What process is D to E? Is it freezing? Is it condensation? What is it? This really comes in your MCQs. I'm not joking. The examiner is just sorry. The examiner is just crazy. So those of you who are saying condensation because you've just learned the thing. It's liquid. So what's the state change of liquid? Liquid, if you cool it down, what would liquid go into? Liquid would go into solid. So this is what the examiner does. He confuses you with an extra line that shouldn't be there just to test your understanding of the syllabus. So this is liquid to solid. It's freezing, please. It's freezing, not condensation. You started off with a liquid. So always check, write it on your head, write it on your chest, that it's always important to see what you're starting off with. Are you starting off with solid? Are you starting off with liquid? Are you starting off with gas? What is my starting point? Please know these things, right? इस मीटिंग से इतना ओवरहीट हो गया, आई गॉट ओके, चलो जी कोई नहीं. सो प्लीज अच्छा, नेक्स्ट explain this again, watch the recording kiddo later. My speed is going to be a little faster, right? It depends on what you start with. If you start off with liquid kidhar jata hai? This is just to confuse you. There's no such thing as this, because after you go from solid, there's no state change after solid. It's just to confuse you. But I've started off with liquid, so liquid would go into a solid. That's the state change if you keep on cooling it. My question to you guys is, what is the freezing point? Let's suppose we talked about H2O, and let's suppose this temperature is 0 degrees Celsius. What's the freezing point? What's the freezing points, guys? Bose-Einstein condensate is not in your course. What's the freezing point? That's 0 degrees Celsius. But what if I ask you a miracle question? That miracle question is, what is the melting point? From this, what's the melting point? From this graph, what's the melting point? Let's suppose it's not 0. Let's suppose I give you this as in maybe like 10. Let's suppose. So what's the melting point? It's 10, it's 10, it's 10, it's same. Remember, freezing point, melting point, same. Boiling point, condensation point. Now, the examiner does these things because you'll realize that he should call it the freezing point, but he sometimes calls it the melting point, just to see whether you'll able to understand that freezing point, melting point, ek baat hai ya nahi hai. Done. This chapter number 1, part 1 is over. Let's talk about diffusion, and then we'll take 5 minutes break. Or phir agla chapter kidhar gaya yaar? Where is it? Sorry, guys, sorry. So this is over, that's over. Let's talk about diffusion now. So heating, cooling curve, interpretation over, changes state, everything over. Describe diffusion. Diffusion kya hai? It's the net movement of particles from a region of high conc to a region of low conc. High conc to low conc. High conc region is just the area of high conc to area of low conc, just like somebody farts, right? So the bum is the source, right? Somebody farts, the bum is the source where the gas is coming from. So the gas goes from a region of high concentration to a region of low concentration, which is your entire room. So it's pressed through the room, it goes into your nostrils. Or let's take a more appropriate example. For example, your mom is cooking biryani. So biryani goes from the kitchen stove, which is a region of high conc, to a region of low conc, everybody, right? And that's what diffusion is. Now, diffusion, one more thing. Do solids diffuse? No, solids don't diffuse. Why don't solids diffuse? Because their particles don't move. They are held together by strong this has never been tested. They are held together by strong intermolecular forces of attraction. Particles are tightly held. Because of strong intermolecular force of attraction, particles are tightly held. They can't move. They vibrate. They don't move. They vibrate. They move. They don't move. They vibrate. Please. So can solids diffuse? No, they can't. Can liquids diffuse? Can gases diffuse? Absolutely, because liquids and gases, they can move. My question, which one would diffuse faster, gases or liquids? Which diffuse faster? Gases diffused faster. Why do gases diffuse faster than liquids? Because they have weakest intermolecular forces of attraction, therefore they have the highest energy. They have highest energies, weakest intermolecular forces of attraction, and therefore highest energies. That's why gases diffuse faster than liquids. Done. This has also never been tested and will not be tested. Next. Diffusion depends on two things. In our course, diffusion depends on two things. What is that? What are those two things? It's temperature and it's the relative molecular mass. First, let's talk about temperature. My question is N2 gas and then there's N2 gas. But one is at a higher temperature. One is at a higher temperature. My question is, which one would diffuse faster? Both can't be tested at the same time. He's either going to test temperature or he's going to test MR. Both can't be tested. Both can be tested at the same time, because then you wouldn't know what is changing. हम जब भी एक चीज की चेकिंग करते हैं तो वी मेक एवरीथिंग एल्स कांस्टेंट. सो हाई टेम्परेचर would diffuse faster. Why? Because देखिए examiner always says tell me in terms of kinetic particle theory. So increase in temperature increases the kinetic energy of particles, so they move faster. Do I need to write about volume? Do I need to write about collisions? Do I need to write about anything? No, I just need to say they move faster, aka they diffuse faster. That's it. Move faster means diffusing faster. It's the net movement. It's just a movement, you know. And then if I talk about decrease in temperature, there's a decrease in kinetic energy of particles and they move slower. Particles move slower, aka diffusing slower. No need to mention volume and whatnot. Move slower, aka diffusing slower. Khatam, 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 boom, shakalaka, that's it. Sir, isn't the movement of particles from high conc to low conc due to their random motion? It is due to their random motion. I never said it's not due to their random motion, but because liquids and gases can move as well. Solids can't move, they vibrate. They vibrate. They are at a constant random motion, but they vibrate. They don't move. You know. So diffusion is the movement. Yeah. Acha. Next, MR. Let's talk about MR, sir. You forgot to mention about. Oh, sorry. In this chapter, we'll talk about evaporation and boiling in the end. Acha. Next, let's talk about MR. MR. The next is MR. MR kya? Relative molecular mass, which you calculate from the periodic table. You sum. How do you calculate the relative atomic mass? Relative molecular mass. It is the sum of the relative atomic masses. It's the sum of the air. So if I take up chlorine and if I take HCl, which is the most common thing that's tested, my question, they put it into a syringe always. This is a cotton bud. This has HCl gas. HCl. It's soaked in HCl. This is maybe soaked in NH3. They take HCl and NH3 a lot, So that's NH3. This is NH3 right here. So NH3 and HCl. My question to you guys is relative molecular mass. Remember, molecular mass is just fattiness, how fat the molecules are. My question to you guys if you have a 100 kg fat person and a 70 kg athletic person, which one will win the race? Sorry, I don't wanna fat shame or body shame, but just sorry. I just want to get the concept across. So you realize that a 70 kg, because he's a lower relative molecular mass, he's gonna win the race, obviously, right? So emotion mein motion nahi hote hain atoms molecules ke, right? So relative molecular mass for your course, maybe, yeah. Achha, relative molecular. So the lower the relative molecular mass, the faster it diffuses. Yeah. So lower MR diffuses faster, higher MR diffuses slower. That's what you need to write. So my question is diffuses slower. Because it's fatter then, right? My question is, sorry guys, don't cancel me. Acha, my question is, the examiner gives you 3-mark question. Where will A, B, C? Where will let's suppose I tell you that these two react to give you a white powder X. Where will X form? X will form at A, B, or C. Where will X form? Near A, B, C. Let's talk about this. So you're going to say, hey, NH3 has the relative atomic mass of what? Relative molecular mass, sorry. Relative molecular mass of what? Nitrogen is 14, hydrogen is 1, times it by 3. You check this out from the periodic table. That's 17. And this is 1 plus chlorine is 35.5. That's 36.5 right here. So realize that NH3 has a lower relative molecular mass. So it's going to diffuse faster, right? Relative lower MR of 17 versus HCl has a higher MR of 36.5. Therefore, NH3 particles diffuses, talk about particles always, diffuses faster than HCl particles. And so where would the white powder X form? Where would the white powder form? At which point? The white powder forms closer to HCl, aka point A, because A is closer. So for the same amount of time, NH3 will have traveled a faster distance than HCl. Yeah, ये NH3 और HCl है, इसको मैं उल्टा कर देता हूँ ताकि confusion ना हो. Ore sajana. That's HCl. That's NH3. Acha, next, I'll show you all the notes. Chill. Acha. Sir, when is it hydrogen chloride and when is it hydrochloric acid? The particles are of hydrogen chloride right here, but I've just soaked it into hydrochloric acid, so it gives you fumes of hydrogen chloride. When you add HCl to a water, when you have HCl in its aqueous solution, then it's hydrochloric acid. Otherwise, in its gaseous state, it's hydrogen chloride, which you learn in organic chemistry substitution reaction. HCl forms, which is hydrogen chloride, not hydrochloric acid. Write it if you did not know this. Acha, last, what's the difference between boiling and evaporation? And then we'll take a 5-minute break. What's the difference between boiling and evaporation, everybody? Hanji, what's the difference? Bataएं जी. Boiling is also a change of state from liquid to gas, and evaporation is also a change of state from liquid to gas. But the difference between the two is that boiling, it occurs at a specific temperature. It occurs at a specific constant temperature, right? For water, it's probably 100 degrees Celsius. And evaporation, it occurs at any temperature. Evaporation occurs at any temperature. In boiling, you have bubbles. You write specific constant temperature, aka same thing. At a constant temperature, specific constant temperature. Boiling, you have bubbles. In evaporation, you don't have bubbles. No bubbles. Boiling is a quicker process than evaporation. Quicker, this is, just summaries. Quicker, slower. And that's it. Occurs, yes, evaporation occurs at the surface and boiling occurs throughout the liquid. पूरे के पूरे liquid में boiling हो रही होती है, throughout the liquid. And this again, what is evaporation? Evaporation is when more energetic surface particles, when more energetic surface particles overcome the IMF and escape into air. And how do they do that? At any temperature, obviously, at any temp. And how do they do that? How do they do that? By taking heat from the surroundings, probably. Isliye, usually for boiling, you need a heat source, and for evaporation, you don't need a heat source. Khatam? Sir, your screen stopped sharing? No, it's still sharing. It's still sharing. And here we go. We're done with evaporation. So that's the concept of evaporation. Has not been tested in a long time, can be tested. Acha, one more thing, everybody. Last concept. Sir, how evaporation causes a cooling effect? Yes, and therefore evaporation causes a cooling effect, leaving a more cooler body behind. I'll also write this here, leaving a more cooler body behind, a cooler body behind. Why? Why leaving a cooler body behind? Why leaving a cooler body behind? Because the more energetic particles leave the surface. More energetic particles leave, so they take the thermal energy with them. They leave, they take the thermal energy with them. So when the more energetic surface particles leave, they take the thermal energy with them and therefore leaving behind a cooler body. Have you ever gone to a football match and come back and put on the fan? Fan से evaporation तेज हो जाएगी ना, आपके कोर्स में नहीं है, but evaporation तेज हो जाएगी. हाँ जी, evaporation is also endo. Evaporation is also endo. It's also endo. Khatam. Now, what you guys need to do is just absorb this. We're done with chapter number 1 and we're going to move on to other chapters very, very quickly. Khatam. Chapter number 1 हो गया, बिल्कुल मुक गया और कहानी इधर क्लोज हो गई चैप्टर नंबर 1 की. तो आप लोग ये चीज़ें देख सकते हैं. मैं 5 मिनट में पानी पीऊंगा और जो है स्टार्ट करते हैं. राइट, सो आई विल जस्ट पॉज द रिकॉर्डिंग हियर.